Welcome to Climate Change, Agriculture and Ecosystem Resilience, CCBD 731 class. My name is DongKyun. This class is a demonstration class, and then you will learn about the climate change, agriculture, and ecosystem resilience in regular class with your professors. I'll briefly introduce the climate change and ecosystem resilience using PowerPoint. So I will share my PowerPoint with you. My presentation is introduction, climate change impact on agriculture, climate change and development, and conclusion. And you can ask me anytime if you want. Okay, first of all, I'd like to tell you about differences in weather and climate. We know about the weather and climate, but we have to distinguish the differences in weather and climate. What is weather? Weather is relatively short-term, and the impact is a limited area. So the weather can be changed rapidly and so difficult to predict. But climate is a kind of a long-term, and impact is wide area. And seasonal changes and measure over long spans of time. So average of many years of weather observation, and from last at least 30 years or millions years. So you have to distinguish weather and climate change. So when we discuss the climate change, not weather change, so we talk about always climate change means at least average of many years weather observation, at least 30 years. And what about the global climate change? This is an identifiable change in Earth's climate, lasts for decades or longer. Usually changes forced by human activities, then changes the atmosphere, so by ourselves. And contribution around 30% from forestry and agriculture, greenhouse gas. Remember, this global climate change caused by the human activities, and around 30% of greenhouse gas came from forestry sector and agriculture. So let's look at more about the global warming and greenhouse effect. I told you about global warming. When the Earth is heating up and the temperature increases. Now the IPCC try to limit the increase temperature 2 points Celsius or 1.5 degrees. And European countries, EU or other countries try to net zero, means emit or absorption of carbon makes zero. So greenhouse effect, when the temperature goes up on Earth, since a process that occurs when greenhouse gas in Earth's atmosphere trapped in the sun's heat. The below left, that shows the suns came into the Earth, the atmosphere, but they cannot go out. They stay in atmosphere because of the greenhouse gas, and around 60% is the CO2, carbon dioxide, and plus some kind of because of this, the CO2, the sun radiation cannot go out, and then this makes the temperature goes up. So carbon emissions from agriculture and tropical forest destruction account for about 20 or 30% of carbon emissions was 15 years ago, 10, 15 years ago was 30%. Now was 20% because of the RDD program, other activities. People try to reduce destroying tropical forest. And then see below right, most of greenhouse gas is the carbon dioxide, 64%. Remember when the Earth was born, 4.6 billion years ago, 4.6 billion years ago, there was there's no the O2, oxygen, only N, nitrogen, and carbon. But carbon is now less than 1%, and oxygen level is 20.95%. And million years, the oxygen level is 20.95. The half from the ocean, and the other half from maybe the forestry sector. And then the population grows very rapidly, maybe 1 billion, and then now almost 7 billions. But the amount of this oxygen level is still almost the same, 20.95. So it's very curious, interesting. So now let's move to the climate change. Climate change impacts. I told you about the human activity. We are the one who caused climate change. So 7 human development is on the tipping points. If you take one step further, it's difficult to return. Decrease in agricultural productivity and increase in water shortage and scarcity. Good, fresh, clean water is lack. You remember lots of the wars in history, starting from the water shortage, water issues, and destruction of ecosystem balance. In Africa, you see environmental refugees. They left their homeland and go to European countries. And high exposure to extreme weather events, heat wave, drought, all these things, and increase in health risks, including new disease, COVID-19, and all the things. High risk of vulnerability of economy and society, and plus now the global carbon emissions. So these all relate with global change impacts. So here we need some kind of the need for adaptations. We have to adjust. We have to survive. So mitigation work only partially. On the ground, we have to adjust. Necessary to organize to take advantage of the new opportunities, longer growing season because it's getting warmer and warmer, so it has the longer growing season, and avoid some of the negative impacts, extreme weather variability and drought. We have to adjust our farming systems, agriculture systems, and resilience. Reducing other threats and larger areas of habitat and larger population, increasing the number of people who live on this earth, and maximize heterogeneity in microclimate and soils, and specific adaptations, and planting drought-tolerant species. because we have to change our agricultural species. If you have the rainforest decreasing, then we have to develop or improve some seed, some rice seed, who are resistant to the drought. So the scientists or the professors or researchers like you and me have to work, do some research and develop some tolerant species. This is what I said, the need for adaptation and resilience. We have to go back. We cannot, just stay and then here, but we have to back to the original state. And building agriculture resilience, enhanced understanding of the role of natural resource space. What we have, water and soil. Soil is most important. All the trees, all the food or vegetables, fruit, where they grow, in water or soil. So we have to understand the basics of water and soil and understand the potential exposures. If the heat and water, longer heat, what will happen? We have to understand the potentiality and focus on extreme as well as mean changes and understand the sensitivities. In a small changes will destroy whole crops and define critical thresholds and interactions. What like one step further, all die. So what's the critical threshold? So we try to keep away that point. Enhance adaptive capacity and resilient systems, climate-ready crops and production systems. We have to bring in, developed. We have to accept those systems. So that's not easy because that takes time. And also what we say, you have to explain and persuade the farmers and then the agriculture companies. Now things coming, now the nature's weathers, climate is changing. We have to adjust. Now you have to use this seed. Now you have to bring the agricultural systems. So here on the climate change, resilience or accommodation. You have to bounce or you have to just live in with these changes, accommodation. If you cannot change, you have to accept and live it. So adaptation means build resilience, bounce, or accommodate change. So here, the IPCC and other like 1 degree, 2 degrees, 3 degrees, 4 degrees. So when the temperature goes up, 1 degree, 2 degrees, 3 degrees, the climate changes, so the approach is different. When 1 or 2 degrees, the resilience, we have to bounce, we have to react. So we have to develop new varieties, new species. But 3, 4, it's very difficult. Accommodation, we have to accept that as a fact. We cannot change. We cannot find, we cannot develop, we cannot improve new species. So 1 or 2 degrees enable persistence, accept the changes. But in the 3, 4, it will be maybe kill all those things. What we should do that at the point? Promote or transformation, changes things. So we have to prepare all these options. Prepare the B plans. If this 3 degrees, what we should do, and the temperature goes up to 4 degrees, what we should do? We have to plan all these things. So, what about the agriculture and climate change? And it has a threefold relationships. Agriculture itself as a contribution to climate change. Remember, the agriculture is a contributor of the climate change. They use the fertilizer, they produce the nitrogen, and then it's one source of the greenhouse gas. And remember the cows, they produce the CH4. And then growing rice also the produce the CH4. So agriculture is the source of the greenhouse gas. Also the climate change impact on agriculture. But at the same time, agriculture itself is a potential moderate of climate change. Increase carbon sequestration through sustainable land management. Soil itself absorbs CO2. Remember, soil itself, there's lots of CO2 is stay in the soil. Or rotation. Remember, you divide by a piece of land area, like 1/4 used this year, and 1/4 next year, and third year, fourth year, you rotate. Or sometimes agroforestry. You grow trees, and in the underground, understory, like cash crops, cacao, and other crops, or banana, you grow at the same time. And organic farming, minimize using the fertilizer and producing the nitrogen and using the animals, the manure, and things like the organic farming. And conservation of tillage, minimize using the machines. And food demand, eventually food demand will rise as human beings, number of people increase. Means there's pressure on agriculture and food insecurity for a large population. So source of 30%, the forestry and agriculture from these sectors. And crops susceptibility to climate change. Very weak, very vulnerable to climate change. Abiotic effects. Crop development and yield impacted by temperature and precipitation changes. And biotic effects impact agriculture productivity and pest occurrence and availability of pollination, about 20% of global carbon emissions. Remember, the bees are pollinated. No. Without bee, we cannot get the fruit and all the fruit and not chestnut things. The number of the bees are decreasing. They are, I'm not sure what kind of the bug are killing the bees. Bees are very useful insect. They produce honey, good for health, but at the same time, without bees, we cannot get any fruit. And climate change effect on production system. More specifically, aggregate effects surpass individual ecosystems. Agriculture is a complex system linked to climate by temperature and precipitation and solar radiation and atmospheric gas composition. all these things change, the production systems are totally changed. Soil, water resources are impacted by the same issues and represented by key components of the systems. So soil, water, and solar radiation, and all these very closely related. The one single factors are affected, the whole systems broke. So climate change effect on soil resources. Soil provide ecosystem services, nutrition cycling. In olden times, we don't give the fertilizer to the soil, but they produce because they're inside. There's a nitrogen is there, calcium there, potassium is there. But because we exploited the soil nutrition, overproduction, nutrition cycling, and delivery of nutrition for food and fiber production, and flood mitigation through filtration and water reservoir, like a forest. Forest is kind of water reservoir. When the rain comes, the trees and forest keep the water inside their branch, leaves, and then soils and roots. And then slowly the water flow to the downstreams. Without the forest trees, the water rushed to the downstreams and flood. And people get damaged. And also filtration. It's natural cleaning the water quality. And structure to support plants, and the trees stay there on the soil, right? And CO2 sequestration and uptake of greenhouse gas in surface and organic layers changing. Oh, of course, the soils take CO2 and also release soil. Remember that CO2 in the Siberia, permafrost, there are lots of the soils there. And it's frozen, they stay there. So the temperature goes up, the permafrost, the Siberian, the soils, the defrozen, the CO2 staying there, coming out, digest. And soil erosion affected by climate change. Remember, without the trees or forests, the mountain area, when the rain comes, all the topsoil is washed away and flood and landslide. People who live down on the edge of the mountains were killed. That's what happened. So studies of field edge effects indicate the major factors: rainfall and intensity. In 1 hour, how much rain falls, intensity. High intensity and short duration is more stronger effect than low intensity, longer duration. And increases CO2 may lead to plant growth and ground cover, lower splash and higher infiltration, but high intensity increase erosion overall. If rain comes too much, then remember why the increased CO2 lead to plant growth? I told you that when the trees grow with the sun and CO2 and water and nutrition. So when the too much CO2, there are enough CO2, and trees grow very well. Well, but there is some point, and slow winter process and increased erosion when melt water flows over defrost the soil on top of frozen soil. Difficult working because the topsoil is messy, and then So if you the spray the seed, it cannot the settle down. It's difficult. So wind erosion by wind impacted by velocity, soil moisture content, surface roughness, and vegetation. The wind is very strong, and then the wind erosion, everything on top was eroded, or the vegetations on top, they are dried and dying because of high wind speed, and they lose the moisture. Remember the windy day, your clothes you wash and you hang out outside, it's dried very in short time because of wind. That's the wind erosion. They dried. The same thing in the vegetation of plants. They lose the moisture. They are dying. So changing production and effect on erosion. So changes in temperature and precipitation and water are changing the types of crops planted, dates of planting, harvest, and tourist and crop management, right? When to plant, when to harvest, all these different. And mixed message of concerning soil erosion. Most studies showed an increase in soil erosion, decrease in fertility, but opportunity for increased management coupled with the temporal or on a spatial scales may result in new models that will more accurately reflect shifts in ecosystem characteristics. Now the vulnerabilities and impacts on agriculture. So regions ideal for cultivation will proceed, maybe north or south, depend on the weather, warmer weather, and expand due to the global warming. Cultivation areas for warming season fruits will expand, like in Korea. However, temperate fruit, like in Korea, temperate area, fruit, trees such as apples, pears, peaches, grapes, I expect to face difficulties if global warming continues. In Korea, it's the same, like here. Apples in Gyeongsangbuk-do area in the southern part, now they move to the northern part in Gangwon province. And parts of the region growing apples may stop growing apple because of the hot weather going on. And some of the, we have the Pinus dense flora, 소나무, Pinus, they stay around all over the Korea. But because of the warmer temperature, only the high mountains area can survive. The lower areas are dying, cannot survive there. So possibility of growing subtropical fruit trees like Taiwan and the Philippine areas, they grow there. In some places, it's expected. In Jeju Island, we cannot grow the banana and then pineapples. But regions growing cool season vegetables will move to north. Due to a rise in average temperature, frost damage has decreased. The damage from insect and pests have increased. A rise in frequency and intensity of damage due to natural, typhoon, heavy snow, drought, hail, yellow sandstorm, heat wave, all these things affect. So I told you about the adaptive measures. So what kind of the adaptive in agriculture? So new varieties or new species suitable to drought, heat, or resistant, and changing climate, or just changing climate, or changing farming practice, and the kind of crops being cultivated, changes in land use, and new watershed management, and introduce agri-insurance because of the sometimes this business get lost money, then you need some insurance. And the forestry is the same. Forest hazard programs should be implemented to avoid the forest fires, landslide. We have getting big forest fires, and policy for maintenance and productivity of forest should be prepared. And planting tree species good for warmer climate, or develop new species. Overseas pest insects are coming, so we have control system, very strict inspection and monitor from subtropical regions, and also networks. We have to study together our neighboring countries. So now time to move to the need for climate resilient development. So remember equal but more inclusive, the UN, the SDG, right? Sustainable development, social, economy, environment, equal. No one leave behind. Everybody go together, right? Without hunger and poverty. And then now here, mitigation, adaptations with the economic development. So climate compatible development. So economic development with climate resilient development. For mitigation, low carbon development. So development, but produce less CO2. Development, climate resilient development. So in the end, we will achieve climate compatible development. So things changed. So in this case, in Ethiopia, the government announced to reach middle income status before 2025. And agriculture was big, but 25 is diminishing weight of agriculture from 40 to 29. Means other sectors are getting more important. And migration from agriculture jobs to service and industry. It happens in most of the countries. So now the Ethiopia is the agriculture country, but moved to the service and industrial countries. We have it now in the electricity, hydroelectricity, reaching middle income status of 2005. Okay. So agriculture in Ethiopia status, many economy is rain-fed agriculture nowadays, which is heavily sensitive to the climate variability and change. In addition, many species with limited geographical opportunities, restricted habitat requirements, and or small population are typically the most vulnerable. And the Ethiopian government has already put in place a number of policies, strategies, and programs aimed at enhancing the adaptive capacity and reducing climate variability and change. I show you in before the slide, the climate resilient green economy, CRGE, focus on 4 pillars: agriculture, forestry, renewable energy, advanced technology. So you move from agriculture country to the industry country. That is support Ethiopia's developing green economy. Remember, developing industrial country means usually the consuming fossil fuels, but not Ethiopian case. Ethiopian case is a climate resilient green economy and developing green economy. That's what I show you, that 2 graphs, CRGE. So agriculture and forestry for climate change. Why this is very important? So IPCC estimated the potential of various carbon removal approaches. Carbon removal by 2050, where forestry or forestation, deforestation. Or forestation means last 50 years is not the forest you plant trees. New planting trees. Deforestation was a forest, but you cut, but leave it, but now you plant. Okay? So agriculture, soil carbon and sequestration in cropland and then grasslands. And what's the other one? Bioenergy and carbon capture and storage. Remember, I told you the CCS, carbon capture and storage. Again, bioenergy. There is some conflict, bioenergy, biodiesel, bioethanol with the food, the corn or maize, right? Biocharcoal also. So there is some conflict, agriculture and forestry, and then the bioethanol, but still agriculture and forestry will do a big role combating climate change and with the affordable cost, very low cost. So then what is the benefit of forest? So the forest can reduce risk of disease, so our health. Reduce deforestation means, according to somebody, US dollar 1.5 to 9.5 billion US dollars worth. And total benefit is 7.7 and 26.9 and billion US dollars. And safety net in times of crisis. It's our home, it's our food, it's our fuel. Forest is, our home. Our food is there. Honey is there, or nuts, bananas are there. The charcoals, and then our energy is there. Income for 20% of global population come from the forest, so safety net. And restoring forest for job creations. One in restoration, $8. $1 spent, $8 benefits. 1 million means, and 500 to 1,000 forest jobs. So if you spend 1 million US dollars for restoring forest, you can create 500 to 1,000 forest jobs. Cash for work program. If people participate in joining in planting trees and all those restoring activities, you can direct payment to the people, the cash to the people. So the economy circulate. So I just briefly introduce climate change, agriculture, and ecosystem resilience. But I didn't spend or focus on the ecosystem resilience because of the limited times and others. But you can study or learn later with your professors. And here I'll focus on and stress one thing. Without farmers, there will be no food. Without food, there will be no life. So you are the students of Hawassa University, Agricultural University, Wando College, studying forestry and agriculture. So be proud of yourself and prepare very well. And once you are ready, once you are ready and you are leaving the university and back to the field and the society, and be proud of yourself, and working for society and the people and country. And always keep in mind that without farmers, there will be no food. Without food, there will be no life. Thank you very much. And I wish you a good luck. And if you have any problems, keep in touch. Thank you very much. Bye.